Number 11 asks us to list the first 10 counting numbers that are prime. And so in order to do that, we need to understand the definition of a prime number. It's a number with exactly two factors, one in itself. And so by saying exactly two factors, that rules out one, because one is the first counting number, but the only factor of one is one. So there are not exactly two factors. So one is not prime. One is neither prime nor composite. The same with 0. The first counting number that's prime is 2, and then 3, because 2 has only two factors, 1 and 2, and 3 has only two factors, 1 and 3. 4 is not prime because it has 1 and 4 are factors, of course, but 2 is also a factor of 4. 2 multiplied by 2 is 4. 5 is prime. 6 is not prime because 6 is 3 2s. 7 is prime. 8 is not prime because 8 is 4 2s. 9 is not prime because 9 is 3 3s. 10 is not prime because 10 is 2 5s. 11 is prime. 12 is not prime. 13 is prime. 14 is not. 15 is not. 16 is not. 17 is. 18 is composite. 19 is prime. 20 is composite. 21 is composite. 22 is composite. 23 is prime. 24 is composite. 25 is composite because it's 5 5s. 26 is composite. 27 is composite because it's 3 9s. 28 is composite, but 29 is prime. So these are the first 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first 10 counting numbers that are prime. Number 12 is a true or false question, but we need to explain our answer by giving an example. If a whole number is not prime, it must be composite. Well, if you think of a number that is not prime, like 4, that is composite because it has factors other than, it has 1 and 4, which would make it prime, except it has other factors other than 1 in itself. So it seems like a true statement at first, because most numbers that you think of that are not prime will be composite. But the key here is it says if a whole number, and what do the whole numbers start with 0. Whole numbers are 0, 1, 2, 3, and 0 and 1, while they're not prime, they're also not composite. And so 0 and 1 are the exceptions. So I'll say false, because 0 and 1 are neither prime nor composite. Okay, problem 13. Find the greatest common factor and least common multiple of 18, 42, and 56. So we'll use our Venn diagram model. First we'll find the prime factorization of each of these. 18 is 2 9s and 9 is 3 3s. 42 is 2 21s and 21 is 3 7s. 56 is 2 28s. 28 is 2 14s. And 14 is 2 7s. Make this my 18 circle, this my 42, and this my 56. I'm looking first for factors that are common to all three, factors that are shared by all three, like 2 is in all three of these trees, so I'll cross 1, 2 off of each tree, place it in the intersection of all three. I have 3s here, and I have a 3 here, but I don't have any 3s here. I have a 7 here and a 7 here, but not here. I have a couple more 2s here, but not in either of these, so there's nothing else in the intersection of all three, so that tells us that the greatest common factor, since the greatest common factor is the product of the prime factors in the intersection, our greatest common factor for these three numbers is just 2. And then let's place these 3's, I'll take a 3 off of each of the trees for 18 and 42 and place that in the intersection of 18 and 42. I'll place the 7 that's shared by 42 and 56 in their intersection. And then I'll complete 18 by putting a 3 in the 18 only. And 42 is complete. I'll complete 56 by putting 2 2's in this area right here. Then I'll check my circles. 3 multiplied by 3 is 9, multiplied by 2 is 18, so that circle checks out. 3 2's is 6, and 6 7's is 42. 2 7's is 14. 14 doubled is 28, and 28 doubled is 56. So I feel confident that my prime factors are sorted into the Venn diagram properly. Now I can find the LCM. The LCM is the product of the prime factors in the union, so all of these prime factors multiplied together. But I can save myself some trouble by realizing that these 4 prime factors already multiply together to give me a product of 56. So I can just multiply that 56 by the prime factors that are outside of the 56 circle. So 56 multiplied by 3 multiplied by 3. 56 tripled is 168. 150 plus 18. And 168 tripled, I'm just going to use the standard algorithm here. 6 3's is 18 and 2 is 20. 1 3 is 3 and 2 is 5. That should be a 0 right there. So 504. So the least common multiple of these are 3 numbers is 504. Okay, the last problem on the review is converting a scientific number in scientific notation to standard form, and then converting a number in standard form to scientific notation. So some things to consider here when we're converting from scientific notation. What type of a number do we expect? Do we expect to end up with a large number or a small number? Since this is 10 to the positive 7th power, we should expect a very large number, because by multiplying by 10 to the 7th, it's like multiplying by 10 and multiplying by 10 again and then multiplying by 10 again. You do that 7 times. Every time you do that, the decimal moves 1 place to the right. I mean, what's really happening is the digits are shifting up to 1 higher place value, but moving the decimal 1 place to the right achieves that same effect. So first we'll write down our decimal number. Try that again. And then my decimal is going to move 7 places to the right, because that's positive 7. 1, 2, 3, 4, 5, 6, 7. You have to do that carefully. If you jump 2 numbers with 1 jump, it's gonna mess things up, and then make these nice and clear, because we're going to fill in these 2 place values with zeros. Show that my decimal is here now, and then I'm going to rewrite my number. 271828 with 2 zeros at the end. Then I can place my commas between the hundreds and the thousands place, and between the 100,000s and the millions place. So 27,182,800. To convert this number to scientific notation, we first rewrite the number. And then we think about where do I need the decimal to be to create a number in scientific notation. The first factor in your scientific notation expression has to be a number greater than or equal to 1 but less than 10. So right now 0.04009 is much less than 1. If I put the decimal here, that'd be 0.40009. That's still less than 1. If I place a decimal here, that's 4.0009, which is greater than 1 but less than 10. So that's where I need my decimal to go. So I'm going to write that number down. That's my first factor. And then I'm going to move the decimal back to where it should be. I'm going to move it 2 to the left to get it back to where it should be. So that's like multiplying by 10 to the negative 2nd power. That's like dividing by 10 twice. But dividing by 10 is the same as multiplying by a 10th. And 10 to the 1st power is a 10th. So it's like multiplying by a 10th and then multiplying by a 10th again. And since we move the decimal to the left, that feels like the negative. That is the negative direction. So our number in scientific notation is 4 and 9 10,000ths multiplied by 10 to the negative 2nd power. Okay, thank you for studying so hard for your test. I know you're going to do great, and I'll see you tomorrow.